Chemistry, Honors Chem AP. This is the day 3 lesson. I'm going to change this. It should actually say day 3. Wednesday is the 3rd day of the school year, of the semester. And this is on More Chem Math. So I'm going to go ahead and just walk through, do all these problems. We did them in class. So first is compute the mean. So mean is an average. So write that down if you don't remember that. It's the average, and you add the numbers and divide by the number of values. I'll omit the units of measure as I'm writing the numbers. We generally don't do that in chemistry, though, or in science. Add these 5 numbers, divide by 5, and you get 3.58, which we are simply going to call 3.6. And now you do put the units of measure. Always put units of measure. 3.6 grams is the average. Compute the percent error. So the formula for that. So it's the true value if there is a known true value. There isn't always, but in this case there is, minus your measured value divided by the true value times 100%. So it says right here that the company recorded that the actual mass of each of the marshmallows is 3.1 grams. So that's the true value. So we're going to go ahead and put this here. Okay, so 3.1 minus 3.6 is negative 0.5. over 3.1, and so that's going to give you 0.161. You can just call it 0.16. Now it's negative, but these are absolute value signs, so they turn the negative into a positive. That's just what an absolute value does. Okay, and then that's times 100%. So the answer is, we'll just round it to the whole number, is 16%. So your measured value, or the student's measured value, was 16% off from the actual true value. Okay, now using a table and calculator, not a spreadsheet, compute the standard deviation of the student's responses. So there were, or the student's measurements, excuse me. So there's 5 measurements, so we're just going to come over here and number them. And we need 4 columns in our table, so we'll go ahead and draw those. You don't need to make the table like this. If you do draw a table, you should do it anytime. You should do it with a ruler. Do it neatly. A lot of crooked lines going all over the place is not helpful in understanding it. But if you chose not to draw the table, that's okay. Just line everything up properly. Okay. Here. Okay, so first is the data value, and those are just the numbers that we were working with, 3.5. Next is the mean, the average, what we came up with was 3.6. It's going to be the same all the way down. Now you have the deviation, or the difference. That's a subtraction. This number minus this, 0.1 there, 3.7 minus 3.6 is actually should be negative 0.1. This is positive 0.1. 3.4 minus 3.6 is negative 0.2. 3.6 minus 3.6 is 0, and 3.7 minus 3.6 is 0.1. Now you square all of these. Use a calculator if you need to. So that would be the deviations squared. So this is going to be 0.01. And if you add those up, the summation of the deviations squared is going to be 0.07. The number of values, n, is going to equal 5. We used 5 values. Okay. The formula for standard deviation is the summation of the deviations squared. That's this number right here over the number of values, 5 minus 1. The formula just calls for you to subtract 1 from that number. You don't really have to understand why. It's just the formula. So we plug that in. We have this 0.07, the sum of the deviation squared, over 5 minus 1 is 4. and then you take the square root of that. So let me show you that on a calculator. Told you I would do that in class. Okay, so let me get this focused here. So first you need to get a square root. If you see the x squared right here, right above it there's a light blue square root symbol. To use any of these light blue symbols that are above the buttons, you have to use this second button, okay? So I'm going to turn the calculator on and clear it. Okay, and I'm going to hit second. Nothing happens, and then I hit the x squared, but that means it's going to activate the function above, the square root. So there's a square root symbol with a parenthesis. So now what I have down here is 0.07. You did not have to put that leading 0 on, by the way. Divided by 4, close the parenthesis. Sometimes that matters and sometimes it doesn't, but you should always close an open parenthesis. So just do it. So now it's going to take the square root of that number. It's first going to compute what 0.07 divided by 4 is, and then it's going to take the square root of it and give us our answer. And the answer is that. You see that. Okay, and we're going to round that to 2 places after the decimal. So we're going to call it 0.13. So that's the standard deviation for this data set. All right. What percent of student measurements, get us back in focus here. What percent of student measurements fall within plus or minus 1 standard deviation of the mean? So let's figure out what plus or minus 1 standard deviation of the mean is. So the mean is 3.6. That's what we computed up here. Okay, up there. Okay, 3.6. If you add to that this standard deviation, 0.13, you get 3.73. Now we're going to go minus 1 standard deviation, 3.6 minus 0.13, and that's going to give us 3.47. So let's just make a little number line here. The mean is 3.6, and if you go plus 1 standard deviation, that'll bring you out here to 3.73 right there. And if you go minus 1 standard deviation, that'll bring you down to 3.47 right there. Okay, so what are our values? Well, we have 3.5. That would fall right in here. Let me just go ahead and write the numbers here. 3.7. That below 3.73, so that would be right about here. We have 3.4. Okay, that's going to be right here. That's outside of plus or minus 1 standard deviation. It's less than 3.47. 3.6. That's right on. That's right where our mean was. And finally 3.7 again, and that's going to be right here again, 3.7. So of our 5 values, 1, 2, 3, 4 fell within plus or minus 1 standard deviation. So 4 out of 5. If you do a little division problem, 4 divided by 5 times 100%, that equals 80%. So that's the percent of students that fall within plus or minus 1 standard deviation. Okay, last question. We learned that about 68% of the values in a normal distribution fall within plus or minus 1 standard deviation. What explains the difference between your percentage and the 68% figure? Well, if 1 out of 5 had fallen in between, that would have been 20%. 2 out of 5 would have been 40%. 3 out of 5, that's what we got. So with only 5 values, you'd have to either be 20, 40, 68, or 100. So you could not have been 68. 68 would have been right, whoops, probably more like right there. But we came as close as you could. We should have either come up with 60 or 80, and we came up with 80. So that's good enough. Another reason is this might not be a perfect normal distribution. Rarely in life do you get a perfect normal distribution. So that's another reason why it might not be right on the 68%. But the answer I gave you in class was this one, that you just can't have 68% there. All right, that takes care of this answers video, and get this assignment turned in if you haven't already.